For nearly a century, we got it completely wrong. There's a world at the outermost edge of our solar system, a world that scientists dismissed as a frozen relic, a leftover from the solar system's formation, too small and too cold to matter. In 2006, humanity made it official. We held a vote, an actual democratic vote, and stripped it of its planetary status. We decided it wasn't worthy. We moved on. Then we pointed the most powerful telescope ever built directly at it. What the James Webb Space Telescope found there didn't just overturn decades of assumptions. It dismantled the very framework we use to understand what a dead world even looks like. Because Pluto isn't dead. It hasn't been sitting quietly in the dark, waiting to be forgotten. It has been doing something, bleeding its own atmosphere into space, painting its moon with stolen chemistry, cooling itself through a mechanism no other world in the solar system uses, and possibly concealing a liquid ocean beneath its surface that has endured for billions of years. The question was never whether Pluto was interesting. The question, the one that should keep you awake, is this: if a world we ignored for 100 years turned out to be this complex, what else are we missing in the dark? The world we invented from nothing. The story of Pluto begins in 1930 with a 24-year-old farm boy from Kansas named Clyde Tombaugh. He had no college degree. He was working at the Lowell Observatory in Flagstaff, Arizona, doing the kind of work that sounds romantic in retrospect, but was, in practice, mind-numbing and relentless. Night after night, he compared photographic plates of the same patch of sky taken days apart, scanning thousands of star-like pinpricks for a single one that had moved. It was the astronomical equivalent of searching a haystack with a magnifying glass. When he found it, the world erupted. A Kansas farm boy had discovered the ninth planet. Schools named classrooms after it. Newspapers ran it on the front page. A child named it after the god of the underworld, and the name stuck. Pluto had arrived, but the celebration, as it turned out, was built on almost nothing. For the next 75 years, everything we believed about Pluto was assembled from the thinnest possible evidence. It was a smudge, a blur of reflected light, too faint to resolve clearly from any telescope on Earth. We knew it was cold, temperatures hovering near minus 230 degrees Celsius. We knew it was small, smaller, humiliatingly, than Earth's own moon. We knew its orbit was a tilted ellipse that swung it inside Neptune's path for decades at a time, then flung it back out to nearly 4 billion miles from the sun. That was essentially the entire inventory of human knowledge about Pluto for 3/4 of a century. It sat on classroom wall charts as the ninth planet, then as a trivia footnote after its demotion, a symbol of how casually we can dismiss something we've never truly looked at. Then, in July 2015, a spacecraft named New Horizons completed a 9.5-year journey across the solar system and screamed past Pluto at 30,000 miles per hour, and nothing about what we thought we knew survived the encounter. The flyby that broke every model. New Horizons had one shot. No Novax, no orbital insertion. No second pass. Just a single, screaming flyby with every camera and sensor firing simultaneously, a 10-minute window to capture as much data as possible before Pluto shrank back into a point of light behind it. What came back shattered every model scientists had built. There was a heart. A pale, smooth expanse roughly 1,000 miles across, shaped almost exactly like a Valentine's Day card, sitting just off-center on Pluto's face. Scientists named it Tombaugh Regio, a nod to the man who found it. And it was anything but a dead frozen plain. The western lobe, Sputnik Planitia, was covered in slowly churning cells of nitrogen ice, convecting like a lava lamp, turning over and resurfacing itself in a way that required heat from somewhere beneath the ground. Mountains of water ice rose nearly 11,000 feet above the plains, taller than any peak east of the Rocky Mountains. Yet they weren't rock. They were frozen water, cold enough and hard enough to behave like granite. A thin nitrogen atmosphere wrapped the entire world in layers of haze, dozens of stacked veils glowing blue when backlit by the distant sun. The images were staggering, but they raised more questions than they answered, because New Horizons kept going and never looked back. Every frame it missed during that 10-minute pass was gone forever. Scientists spent years mining every pixel and spectrum from the flyby data, publishing hundreds of papers, building models, and tearing them down. But there was a ceiling on what a single flyby could reveal. That ceiling was about to be removed. When the James Webb Space Telescope began its systematic observations of Pluto, starting in late 2022, it wasn't taking portraits. It was taking fingerprints. Reading the chemical signatures embedded in every wavelength of light, reflecting off the surface and radiating from the atmosphere. Webb didn't need to be there. It just needed to stare from its position roughly 1,000,000 miles from Earth and let the photons carry their secrets home. What those photons told us was deeply, unsettlingly strange. What Webb found in the dark. The first revelation from Webb was about the atmosphere, and it didn't make sense by any framework scientists had built for worlds like Pluto. Pluto's atmosphere is extraordinarily thin, roughly 100,000 times less dense than Earth's sea level air. But it exists, and it's layered with a complex organic haze produced when ultraviolet sunlight, faint as it is at Pluto's distance, breaks apart methane molecules high above the surface. The fragments reassemble into heavier compounds, ethane, acetylene, ethylene, and eventually clumps of reddish-brown organic particles called tholins that drift downward and coat the surface. Back in 2017, planetary scientist Shi Zhang at UC Santa Cruz had proposed something that seemed almost too strange to publish. Pluto's haze wasn't warming the atmosphere the way similar hazes do on Saturn's moon Titan. It was cooling it, absorbing sunlight and radiating that energy away in the mid-infrared, bleeding warmth into space faster than the atmosphere could recover. The planet was using its own atmospheric particles as a refrigeration system. In 2023, an international research team led by Tanguy Bertrand confirmed this directly using Webb's mid-infrared instrument. Zhang had been right. Pluto's haze actively chills its own atmosphere. No other body in the solar system, not Titan, not Mars, not any moon or dwarf planet studied to date, behaves this way. And nobody can fully model where that cooling process ends. But the second discovery was more visceral. Pluto is leaking. Methane molecules, light enough to escape Pluto's weak gravity, drift constantly upward and vanish into space. Scientists had suspected this for years. What they couldn't know, until Webb confirmed it, was where that escaping material was going. It wasn't lost. Something was catching it. Pluto's largest moon, Charon, about 750 miles across and locked in a tight gravitational embrace roughly 12,000 miles away, has no atmosphere of its own. Its surface is ancient, cratered water ice, mostly uniform in color, except at its poles. Both poles are stained a deep reddish-brown, darker than anything else on the moon's surface, sitting there like old bruises. In a series of Webb papers published across 2024 and 2025, researchers confirmed what had long been suspected. The stains are made of Pluto's own escaped atmosphere. Methane molecules drifting from Pluto get captured by Charon's gravity, freeze onto its poles during the long Plutonian winter, and are then broken apart by sunlight and cosmic radiation into the same heavy organic compounds that color Pluto itself. Pluto is exhaling, Charon is inhaling, and Charon's face is being permanently dyed by the chemistry of its neighbor's slow, ongoing loss. Nothing else in the solar system does this. No other world is actively feeding a moon with the remnants of its own escaping atmosphere. And this exchange has been happening continuously for billions of years. The ocean at the bottom of the world. All of this, the bleeding atmosphere, the cooling haze, the organic chemistry, points toward a question that sits at the edge of everything we thought we understood about where life can exist. Beneath Pluto's frozen surface, something may be liquid. The evidence is circumstantial but consistent. The surface of Pluto, particularly around the heart region, bears a pattern of fractures and ridges consistent with what planetary scientists would expect if a body of liquid water sat roughly 100 miles below, kept from freezing by the slow radioactive decay of elements locked in the rocky core. Sputnik Planidea's shape and position suggest a positive gravity anomaly directly beneath it, something denser than ice sitting underneath. Liquid water fits that description precisely. South of the heart, two enormous isolated peaks rise out of the surrounding terrain. Right Mons stands roughly 13,000 feet tall. Pikar Mons reaches perhaps 20,000 feet, with a footprint that rivals Mauna Loa, Earth's largest active volcano. Both have a deep central depression at the summit, ringed by concentric fractures, with flanks that look strikingly like the cooled flows of terrestrial volcanoes. They're almost certainly cryovolcanoes. Mountains that once erupted not magma, but a slurry of water, ammonia, and methane pushed up through the ice from somewhere deep inside. The eruptions appear to have occurred in the geologically recent past. Something generated heat sufficient to liquefy material and force it to the surface. And if that heat source has persisted, the liquid reservoir below may still exist. If it does, the implications are staggering. A body of liquid water sealed beneath ice harder than anything on Earth, in total darkness, billions of miles from the sun, fed by organic compounds slowly sinking from the surface above. An environment entirely disconnected from starlight. And here on Earth, everywhere we find liquid water and an energy source, we find life. We cannot reach it. Not yet. No Pluto orbiter is currently funded. The journey takes the better part of a decade, and the engineering required to actually pierce that ice and sample what lies beneath is, at present, beyond us. Webb continues to stare when Pluto rotates into its observable window, refining the chemistry, tightening the models, building a picture one data point at a time. Every observation makes Pluto stranger and more significant than it was the day before. There are hundreds of thousands of similar worlds in the Kuiper Belt alone, potentially trillions more in the Oort cloud, stretching nearly a quarter of the way to the nearest star. If one world we dismissed for a century turned out to be bleeding, cooling itself through a unique atmospheric mechanism, dyeing its moon with stolen chemistry, and possibly harboring a subsurface ocean, then the dark is far more crowded and far more alive than we ever permitted ourselves to imagine. We didn't demote Pluto because we understood it. We demoted it because we hadn't looked. Now that we have, the universe feels considerably less empty. If you enjoyed this journey into the mysteries of the universe, don't forget to subscribe for more fascinating stories from space and beyond.